Welcome, everyone, to the first part of our Earth in Crisis series. My name is Aurelio Muraca. I am the technology coordinator here at the Danbury Library. On behalf of the Friends of the Danbury Library, I want to welcome you for this special talk this evening. Tonight's talk is part one of a four-part series, and tonight's talk is about climate refugees, past and future. Droughts and floods have dislocated people throughout history. And as Earth's climate has warmed, both wet and dry weather events have grown stronger and more frequent. So more and more people are, particularly the least responsible, bear an increased burden in trying to find new places to live. So we're going to begin our presentation this evening with Dr. Stephen Mitch Wagener of the Western Connecticut State University. And Mitch, welcome.
Thank you. Thank you. I always enjoy doing this. I want to make sure you can hear me all right.
We can hear you.
Okay. All right. I'm a professor at your friendly neighborhood state university, WestCon, down the road from almost everybody. And I'm a friendly neighborhood ecology professor that lives in Bethel. I've been here for this is my 26th year at WestCon. And yeah, it's home. It really is home. Please forgive a little bit of congestion. I live in an old house and there's a few allergens in here that I don't seem to be able to get rid of. All right, come on. Oh, there we go. Well, we're talking about migrants. We're talking about people who are put outdoors and on the road without actually meaning to. People who have been dislodged from their homes because of economic problems, also those that are caused by severe weather and it's combinations of human activities, which were not very well considered, and and weather activities, which are outside of our control. There are a couple of pictures that are here that are taken by Dorothea Lange back in the 1930s, who was an excellent photographer, and she took a lot of excellent photographs of these migrants and the Dust Bowl, which we'll be talking about as part of this presentation. Climate refugees. There are climate refugees right now. Anytime that a person is dislodged from their homes, they lost their farm because of a change in climate, or because of sea level rise or so on, and they have to find some other way to feed their children, they are in fact climate refugees. I always like to show a picture of Earth just to get people a little bit of perspective. I usually show the Apollo 8 photographs to remind everyone how beautiful Earth is. This one's a little bit different. This is a photograph of Earth taken from the surface of Mars. And just think about all the arguments we have and all the disagreements and all the yelling and screaming and the whatever keeps us from liking each other and cooperating each other, all out there on that dot. So, just, gives us a little perspective, I think. All right, come on. Okay. Now, it's probably best, even if you see my talks before, it's probably best to explain the difference between climate and weather. People get them mixed up. Climate's large scale in terms of space and time, and weather is small scale. Weather is what I see when I look out the window. Well, except for it's dark now, but weather is what hit us this weekend when we got that snow. Climate is something that is it is temperature and humidity and atmospheric pressure and wind and rain and all that over a large area over a long period of time. When climate scientists talk about climate change, they are basing that notion of change on at least 30 years worth of data. Okay, that's the statistical rule of thumb about how much data information you need to actually say that the climate is changing, and we have plenty of it. So climate's what you expect in a given area. Weather is what you get. Now, just to give you, a little introduction about where things stand right now, before we get into the human part of all this, of course. There are a number of organizations around the world that will collect data. They'll actually get data from NOAA mostly, and NASA, and the European Space Agency, and other large groups that have collected data from around the world, usually from satellites, because satellites are whipping around all the time and can collect a lot of data. And they will, munge it all up in the computer and see what comes out. And these peaks all represent years, and these are up until 2021. These were the 10 warmest years on record. Looks like 9 warmest years on record. You can add 2021 to that. 2021 is now about around similar to what 2018 is. Not the warmest, because it was a La Nina year, which might be, that should be the topic of a future presentation, El Nino and La Nina. But it explains why it wasn't as hot as some of the others. All right, moving right along here. This graph is from NASA, and I believe I got the graph itself from New York Times. And you can see that little dark circle there is this year, or 2021, last year. And it was the 7th, either 6th or 7th, depending on exactly where that dot is in history. Now, you have to remember that climate was much warmer in the past, but that was long before humans were around. So we bear no responsibility for it, and we did not suffer the burden of it. Back in the days when dinosaurs roamed the earth, at times they were quite warm. Back in the days when our current fossil fuels were being grown, because they were actually the living organisms at that time before they became fossilized, it was quite warm then as well. So when scientists talk about human history or history, they're really talking since about 1800, because that's how long we've had the ability to collect enough data to make estimates like this. Another way to look at this is to look at it in one year, but look at every place on Earth. And the map such as this for 2021, I don't think is fully operational yet. They don't have all the data plugged in, but you can see how it all works. Any little spot on the Earth that's blue is cooler than a baseline. In this case, the baseline is 1951 through 1980. Anything in yellow, orange, and red is warmer. You can see how warm it was in northern Russia. This is a new kind of graph, which I find fascinating. I can sit there, I'm a nerd anyway. I can sit here and look at this thing forever. And this basically is a graph showing representing each one of the countries, or many of them, as circles, with the temperature, average temperature as compared to this 1951 to 1980 average. So anything that is yellow, red, or brown is warmer than that baseline. Anything in blue, and I don't see any, is cooler. And anything with a black line around the circle is the warmest year in history. So Russia, warmest year in history. We saw that. This is 2020. There'll be one of these, no doubt, made for 2021 as well. If you're a geography nut, you could sit and stare at this for a while. I could. Now, not only are things warming up, the things are either getting wetter or drier, depending on where you are. This is a map showing how annual average precipitation has changed during the years, on the average, during the years 1984 through 2016, as compared to the mid 20th century average. And the upshot of it is just to see what's brown and what's green. That which is green is wetter than the 20th century average. That which is brown is drier, and some of it is much drier. So one of the areas that we're going to be talking about is sub-Saharan Africa, where you can see there were some spots of extra rainfall, but a lot of it's just dry. And there's other areas like Indonesia where Borneo is as wet as it can be. Thailand, where I used to live back in the 70s when I was a kid, is pretty dry at the moment too, as compared. All right. Well, the reason why all these changes are happening, of course, is that human activity, as a waste product of human civilization, as it's practiced now, releases gases into the atmosphere, carbon dioxide being one. There are others. There are stronger ones, there are weaker ones. Water vapor, by the way, is a very common, abundant greenhouse gas, and it just it's not very strong molecule by molecule, but nonetheless, there's so much of it that it's significant. Well, CO2 is what we get primarily when we burn fossil fuels. And this gentleman named Keeling, back in the late 50s, invented a gizmo for measuring carbon dioxide accurately in the atmosphere. And it may have been infrared, or it may have been an infrared gas analyzer, I'm not sure. But anyway, he collected data and other people have collected data, and you can see the zigzag, which is the carbon dioxide going up and down within a year by seasons, depending on whether it's the northern summer where all the trees are, or the northern winter where there are not so many trees in the southern hemisphere. So that zigzag is every year, and you can see the trend, even with the zigzag, is up. And if you look real closely, it looks very much like that line is not linear, which means acceleration of some bit. All right. Okay. Now, the amount of carbon dioxide in the atmosphere has gone up and down since there has been carbon dioxide in the atmosphere. And, going back 4 billion years or so. And humans, of course, have only been around for the last, in our anatomically modern form, 250,000 years. And you can see here is the CO2 concentration in the atmosphere for the last 800,000 years. Now, someone will want to know where we got that information. Well, when you take a core of ice, there's air bubbles trapped in the ice, and we can tell how old that ice is. You can pull the air out and analyze it, and you can see how much CO2 there is. And a lot of this kind of work has been done. So the upshot of it is you can see as the CO2 goes up and down starting 800,000 years ago, which years are likely to have been warm years, which ones probably were ice ages, because ice ages are fairly common. And those where the CO2 concentration is low will probably be icy, and those where it's high would probably be pretty warm. And you see that over that 800,000 years, the amount of carbon dioxide in the atmosphere never exceeded 300 parts per million until very recently. Okay, and the precipitous nature of its increase is notable. Now, we know, not from this graph, but we also know where that extra carbon came from. That is probably the subject of a separate talk in the future. It has to do with isotopes. Now, climate change is not just one thing. It's not just carbon dioxide in the atmosphere. It's not just temperature, air temperature at the surface warming up. It's all sorts of stuff. The humidity is going up. The temperature over the land's going up. The temperature over the ocean's going up. The glaciers are melting. The snow cover is melting. Tree lines are shifting toward the pole and upward and so on. And each one of these factors you can measure, and they are being measured separately by different scientists in different parts of the world. They're all independent merit measures. In fact, and each one of them point in the same direction, the fact that the climate's warming up. In fact, if you really wanted to know whether the climate's warming, you wouldn't have to look any farther than the ice. If the world was not warming year after year, the ice volume would not be decreasing, melting and decreasing year after year. That's the thermometer right there. Now, where does all that heat go? That heat that's trapped in the atmosphere is almost entirely moving into the oceans. And it's because water will hold and attract more heat than will air. The water cools and warms more slowly than air does. Okay, so the ocean is this big sink of heat, that is being drawn into it from the ocean. And in fact, you can look at how much heat has been added to the ocean over the last, since 1958, looks like. And you can see that it's pretty significant. This is not temperature. This is a measurement of the amount of heat in joules and fraction. In multiple of the units of energy that physicists use called joules. Zettajoules, exactly, 10 to the 21st joules. Now, one of the outcomes of heat being trapped in the ocean is the ice that is floating on the ocean, like that which covers the North Pole, is being melted. And the importance of that ice, well, one of the most important is the fact that ice reflects sunlight back up into space, which you will know if you go driving around town or walking around town on a sunny day after a fresh snow in, say, February, where you have to put your sunglasses on because the reflection of the sun off the snow is too bright for you. That's what's called albedo. Albedo. And open water, on the other hand, has a low albedo. Snow reflects over 80% of the light that shines on it, reflects or scatters. Open water only reflects 8%. All right. So when you take the ice of the north of the Arctic Ocean and you melt it, you're replacing a 80% reflective surface, high albedo, with a 8% reflective surface, a low albedo. And what that means is the warmer the water, the more the ice melts. The more the ice melts, the more sunlight can warm the water, and the more the ice melts. It's a positive feedback system, a non-linear response. And earth science is full of these kinds of responses. Climate refugees. Well, all organisms on Earth are going to be affected by the changes that are going to come. Humans have some ways of sheltering themselves to some degree, but nonetheless, there are going to be lots of our fellow residents on spaceship Earth that are going to find themselves outdoors and on the road. Some of them will be set adrift by wet conditions, and some by overly dry conditions. Now, one of the wet conditions that's going to be hard on folks that live near the oceans is sea level rise. Now, there are two major factors that can raise sea level rise. One is you can demonstrate this in your kitchen. Whenever you take cold water and you warm it up, that water expands. Those water molecules want to be farther away from each other. And if you take a glass and fill it half full of cold water from the fridge and mark it with a wax pencil or something and let it warm up to room temperature, you'll notice after it warms up, the level inside that glass will be higher than it was before. Okay, and that's just what the ocean does. So whenever you warm the ocean, all that heat that's going in the ocean is causing the sea level to rise to some degree. The other thing is that if you take ice that is up above sea level, up on Antarctica or up on Greenland, and you melt it or chunk it off so that the ice falls into the ocean, both of those will raise sea level. So any combination of those factors will in fact raise sea level. Now that's sea level rise, which is pretty constant year round. You can raise sea level significantly short term by having hurricanes, which we'll talk about that in a minute. Hurricanes. So hurricanes are one of those blessings that we're going to have more of in a warmer world, because warm water makes for stronger hurricanes. So tropical depressions, more of them will become tropical storms. More tropical storms will become more hurricanes. More weak hurricanes will become stronger hurricanes. Okay. And so with the increase in heat in the ocean, our storms will get stronger. Not only that, but our nor'easters are going to get stronger too, because nor'easters get their energy from the contrast in temperature, the cold water on land and the warmer water in the ocean. And you warm that water up in the ocean, and that makes that storm, that nor'easter, stronger. That means that those storms will be bigger. They will pump more moisture up on land in the form of heavy rain, heavy snow, and bombogenesis. That's something that you'll hear more and more about. Now, what happens when you have a big storm? The wind blows across the surface of the water. And as it does, it exerts friction to the surface of that water and pushes it ahead like a bulldozer does, or a snowplow pushes snow. So you can see this diagram. If the mean sea level is that bottom line and the normal high tide is 2 feet above that, well, then a storm surge can push that water an extra 15 feet above the normal high tide. Add that to the 2 feet of the normal high tide if your storm hits at high tide, and you get 17 feet of storm. And that means that far more property and agricultural land and natural environments like marshes will be wrecked, damaged, torn out, and destroyed as the storms get stronger and the sea level gets gets higher. Now, that may not seem all that, terrible sounding to me living up on my hill in the middle of Bethel. But if you happen to be a Bangladeshi living in the Sundarbans, this great big delta formed by the rivers Ganges, Brahmaputra, then they're going to be in a world of hurt. You see how high the water is relative to their homes. You get a storm surge, you get a sea level rise, you got people who are not able to get up and go places other than as refugees. I mean, these are people who are not responsible largely for putting a lot of CO2 in the atmosphere. They're not responsible for causing the pain, which they will suffer themselves most acutely. But they will feel it because they have not the ability to escape it. And their world is full of people like these Bangladeshis. There are, I don't remember the number, 16 million people in the Sundarbans living within a meter of sea level. In a couple of countries over, you have Thailand and Bangkok, big city of 10 million people or so, is right at sea level and sinking. It's sinking because they've overbuilt big buildings and they've pumped a lot of the water out of the aquifers underneath. And so the land is subsiding. At the same time, you have sea level rise, and you have periodic flooding, and you have potential of cyclones, as they call them there. And it's going to be a big mess. Now, you have situation where the government's resistant to doing anything about beginning to move people away from the danger zone, because that might spook the markets, that may harm business. And the government seems to be much more concerned with financial issues than they are people. But these people are, imagine having a great disaster where people can no longer live in Bangkok and you have to move 10 million people. How do you do that? You know, think about the human suffering there. I mean, I have family in Thailand, adopted family. I was a foreign exchange student, and they don't live near Bangkok.
Where'd it go?
But it's just an extraordinarily painful scenario to think that they may get caught up in this. Where am I? Now, not only in places like Bangkok or Bangladesh, but all along the Gulf Coast are going to be vulnerable. And you know that in Louisiana, the road signs are shaped like the boot of the state of Louisiana, and they'll have that outline of the state and number 5 of the Troop 5. Well, the thing is that Louisiana isn't that shape anymore. The sole of the boot has come off. And there's a lot of areas around the Gulf Coast, all the shoreline of Texas and southern Florida, and you know, the eastern areas of Virginia, North Carolina, all the way up in lower Manhattan and Back Bay of Boston, and not to mention Atlantic City, that are vulnerable. You remember what a mess Superstorm Sandy was? Well, that's just a warm up. All right, now another thing that's related to all of this we should keep in mind is the human population is growing. Okay, if you look at the population estimates and this is from United Nations population group, you can see that currently it seems that there may be the first hint that the human population may be leveling off a little bit. One of the problems that we have is we have a lot of us, and we need to have fewer of us, and this would make a lot easier to manage climate change. And what I mean is that the human population can have more humane lives if we are not grossly overpopulated. Now, one of the things that we can see with populations of organisms is that there is often a level of population called the carrying capacity. Carrying capacity is the amount of organisms, of the organism in question, that can be sustained indefinitely based on the resources in a given environment. So you can think about the carrying capacity of deer, the carrying capacity of mice, the carrying capacity of bumblebees, you know, in a given location, and the carrying capacity of humans too. This is, for most organisms, it's about the amount of food, water, and requirements provided by the environment. With humans, there's another aspect as well, and that is the amount of consumption per capita. So one way that we can help to reduce the burden of of a lot of people is for more of us who probably consume more than we should to consume less. Because what happens in natural populations is that population that is growing may overshoot its carrying capacity. And as it does, it degrades the environment. And so the ability of that environment to carry, to sustain that population is going down. And so you're by having too many organisms of a particular sort in an area that will not hold that many, you have a situation where the number that can be sustained decreases over time. And it would be a mistake to think that does not apply to humans as well. All right. Well, going back to the beginning of modern humans, anatomically modern humans, we have always been migrants. Our ancestors were originally from East Africa. We can trace genetically our most recent female descendant or ancestor, the one we call mitochondrial Eve, back to about 250,000 years ago. And we can track females. We can interpolate back to determine when this particular woman roamed the earth approximately, because we are looking at the DNA from mitochondria, one of the little parts of the cell, which you only inherit from your mom, and you don't inherit it from your father. So you can look and see how much has changed and go back in time. Well, the mitochondrial Eve, the woman, the hypothetical woman who is the mother of us all, from East Africa, and at some point, her descendants left East Africa, probably because the climate had changed. The animals and the plants and animals which they rely on were no longer so easy to find, and they had to move to those places where they were. And just like organisms do now, I mean, if you ran out of food for deer would move someplace where there's more food. And humans are no different. And we basically spread out through the entire world, with the exception of Antarctica. We have people in Antarctica, but they're just temporary. And our ancestors reached South America about 15,000 years ago, more or less. All right. So moving in response to a negative change in the environment is a normal thing for humans, going way back. One of the most noted historical examples out in this country was something that happened back in the 30s, what was called the Dust Bowl. And it includes lots of people's ancestors, including two of my grandfather's brothers. I had a great uncle Cecil and a great uncle Thurbert. Really, that's their names. They were from Hontubby, Oklahoma. And my grandfather, their brother, stayed and moved into Missouri, but Uncle Cecil and Uncle Thurbert moved to California. They were Dust Bowl Lokies. So it is a story, that is part of my family. Well, what happened was that before World War I, there was a kind of a wet period in this zone in the Southern Plains, and people sort of assumed that the conditions as they were then were permanent. And so, and plus the demand for wheat for World War I for feeding the troops caused the price of wheat to go up. And so a lot of people moved in and replaced this native vegetation, which was quite good at handling whatever came, wet or dry, and supported buffalo and all that, and replaced that by busting off the sod and replacing it with a new variety of wheat, which had just been imported. As long as the rains held out, the wheat grew and people made a living, and those people who were speculating, and there were a lot of speculators, made money growing this stuff. Well, as it turned out, that wet period was not, in fact, normal. It was a temporary condition. And so after you busted up the sod, one thing the native vegetation did was held the soil in the roots, okay? And when you busted up the sod and planted wheat, then there was nothing holding those roots anymore. And this lovely native agriculture became the Dust Bowl. The conditions dried to their natural state or their average state, and the winds picked up dirt and carried it all over the place and covered up, filled up people's houses with dust and covered up their farms. People would say that they could tell where the storm was coming from by the color of the dirt, because dirt from Kansas and Oklahoma and Colorado and Texas was all different colors. I don't know if that was true or not. They did. But you have a lot of people who had no way of making a living after a year or so of not being able to farm. And so what do you do if you cannot feed your children? This is one of Dorothea Lange's photographs. It is a companion taken at the same time as one that was a close-up on the mother here on the right when holding the baby, which is a classic. One of the great photographs ever taken is the care and worry and difficulty that mother was having with those four children. And what did people do? They got up and left. They got in their old beat up cars and headed for the promised land, as they thought, and that was California. And you probably read The Grapes of Wrath or seen the movie. And a lot of those folks were met at the border by state police who said, no, you can't come here. We have trouble feeding your own. You got to go somewhere else. Americans saying that to other Americans. It can't happen here. Now, more recently, something similar happened in the sub-Saharan Africa called the Sahel. They had a brief wet time where a lot of people moved into the previous dry country and created farms. And then after a few years, these farmers, which were not very well funded, I mean, they didn't have a lot of money, lost it because the weather turned dry again. Now, if you have children and a family and you're trying to feed them and your means of feeding your children disappear, what do? Well, you may go into the towns or in the cities of that country and try to find work in some fashion. Or you can try to move into, make it into Europe, okay? Or you can join extremist groups, all of which has happened. So in the Sahel, there's more than 300 million people struggling with food insecurity, not enough to feed their children. 1 in 5 children under the age of 5 suffers from acute malnutrition. 4.9 million people have fled their homes. Desperate people join extremist groups and they do desperate things. The truth of it is, our future, the future of humanity, we're all in this together, is hundreds of millions of climate refugees, and some of them may be us. If our homes are too close to the ocean and things go bad, or it could be members of our family, it can be, in fact, anyone, just about, even me up on top of my hill in Bethel. But there is hope. There's hope because so many of young people in this country and around the world get it. They understand what's at stake. They understand their life and their future that is in the balance. And a whole bunch of them have decided to stand up and speak up and don't shut up. You may recognize Greta Thunberg, the young woman in the purple jacket here in the front. She's got Asperger's syndrome. And she says that because she has Asperger's, she cannot avert her eyes to the world. And she sees that as almost a superpower. And I admire that attitude a great deal. So there are things that individuals can do. There are things that must be done in larger collectives like governments and corporations and so on. What we can do as individuals is we can educate our children about climate change, because they're going to face it. We won't, not in the same degree. We can support climate education in our schools. I am a climate educator. I will do that until I fall over. There are a whole bunch of oil wells that have not been tapped properly when the oil dried up, which allows methane, natural gas, to spew from them unimpeded. We need to cap all those things, because methane is 17 times as strong a greenhouse gas as CO2 is. The chemicals that we use in air conditioners and refrigerators as refrigerants are the devil's own greenhouse gas. They're thousands of times stronger as greenhouse gases than CO2 is. We need to find alternatives that are not flammable. There are some options. We need to educate all the girls on planet Earth. We need to make sure that family planning available, optional to all women. Girls who are educated will start on average families later in life. They will have healthier children. They will educate those children. It is a incredible net positive all the way along. And it also will free half the human population. There are things that we can do as collectives, as groups, especially those of us, this group, in a democratic nations. We can figure out what our values are and vote them. Talk to the local, and this applies to local candidates as well as national candidates. Find out how they feel about this stuff, and vote for the ones that reflect your values. Speak up with your voice, your time, your money. Be active in state and local affairs. You can, and I can, burn less carbon ourselves, and we should do that, but that is not going to fix the problem all by itself. We can electrify and purchase renewable electricity. It doesn't help to have an electric car if you are recharging it with electricity that was generated from a coal plant. We can eat less meat. Not none, but less. Maybe most important, we can be compassionate. We can teach our children and our grandchildren to be compassionate. We can demand that our elected officials demonstrate compassion in the policies they enact. Albert Camus, a French novelist, wrote in a novel called The Plague, which is a story for our time, although it wasn't written recently. He says, main character says about the way that we fix the plague. I have to tell you, the whole thing is not about heroism, it's about decency. It may seem a ridiculous idea. The only way to fight the plague is with decency. And I might add, me, not Camus, saying that the way we're going to overcome climate change and make a world safe for our grandchildren, and I have one, is through human decency. It's real. It's us. Experts do agree. It's bad, but there's hope. But there isn't much time. So I urge you all, as I do every day, stop and think. Okay. What's best, not just for us as individuals, what's best for our grandkids? How many times did we demand that our children clean up their own mess? Well, they have every right to turn that around on us now and say, demand that we clean up our mess. I believe that's all I have, and I would be delighted to answer questions if anyone has any.
Please, thank you so much, Mitch.
You're welcome.
Everyone, if you have any questions, please type it in the chat, and I will relay it to Mitch. And I always thought, Mitch, just on my behalf, is always with my kids, start small. Tell them, you know,
Yep.
a little bit here, a little bit there. It makes a difference. You know, the world doesn't change, you know, overnight, but little ripple effects do have an effect long term. So we do have a question. What are your thoughts on natural gas?
Natural gas, I say that as someone who, at least for now, is using it to heat my house along with my wood stove. I would plan on changing that at some point. Natural gas is relatively clean compared to other fossil fuels. It's certainly better than fuel oil in that regard, but it is easy to leak. It's methane mostly, and methane is a very strong greenhouse gas. When you burn it, you are converting it from a strong greenhouse gas to a less strong greenhouse gas. You're converting it from methane to CO2. So it is better than, certainly better than coal. It's better than fuel oil. It is something we need to move past eventually as well. But I'm certainly not going to criticize anybody for using it if they need to, because I do for a while.
There's going to be a you know, a transitional period that we're all going to go through, and you know, I use natural gas too, and you know, there's going to be a, you know, a transitional period, and I think that we're moving into now. That's, you know, we're moving away from internal combustion engines to more, you know, electric vehicles. We're moving away from, you know, getting our power from, you know, coal companies and, you know, other, you know, companies that, you know, are not environmentally, you know, sort of, or sustainable for the earth. But we're getting there. There is another question.
And this relates to the next question.
Yes, it does. And that's one thing that I always, you know, this is a great question. Is this always, you know, it's a back of my mind, especially with electric cars, is what happens to the batteries used for electric cars and to solar panels when they wear out? Are they safe?
Well,
so,
and like anything,
everything or recycle. You know?
Everything needs to be disposed of or recycled properly. Okay. Now, there's a lot of engineering that needs to be done, because well, let's not fool ourselves. There are, you know, electric cars are on balance better than gas cars, but there are problems that we need to overcome with them. Okay. For instance, some of the metals that are used in batteries are ones that have a high price in their mining. But if some genius of an engineer wants to come along and figure out new ways of recycling cobalt and lithium, you could probably make a ton of money and do the world a great shake. Okay, so what we need to start thinking about is how to recycle these things. And I'm not an engineer, so there's very little I can add to the discussion of that. but there are people who are actively working to figure out ways to make batteries use less of these expensive and metals such as lithium and cobalt, and how to reuse those things so we're mining less of them.
I
That's
agree.
about it. That's really the only thing I can say about that.
That's something that I think, and any engineers who are out there, you can't do it, inspire the next generation and the next generation after that to figure out
Yeah.
these problems. And we'll figure it out. But, at this time, it's a problem that needs to be addressed. And thank you for
Sooner the
that
better.
question. Yep, exactly. The next question is, let's see, expand on the
Population level.
reasons why global population is leveling off.
Well, there's probably several reasons. One is that in more countries, girls are having a chance to get more education. It could also, in some countries, China notably had a fairly draconian one-child policy, which they have decided to reverse to some extent because now they don't have enough young people coming up to fuel the pyramid. And so that they're having to weaken those sorts of things. There's lots of people who see a world that is full of trouble, and they don't want they're less eager to bring children into it. I don't know if that is as a good motive or not. I cannot make that judgment for other people. I think those are the reasons. And also, some countries, the birth rates are going down big time, like US and in Europe and Japan and Russia too, for that matter.
Oh, yeah. Next question. Are there any new inventions that would be used to rid the atmosphere of CO2, or will this most likely be done via a natural means, such as by plants, trees, etc.?
All the above. I mean, one of the issues with pulling CO2 out by planting is you're using land that might be needed for agriculture. Those things have to be taken into consideration. There are not only trees, but there are plants that grow fast, such as bamboo and hemp, which can be used for construction. That if you grow something like bamboo or hemp and use it in construction, it's not decomposing, and so that carbon is out of the atmosphere, at least for a while. Okay, so those things are good. There are mechanical and electromagnetic gizmos under development for pulling CO2 out of the atmosphere. The trouble is they do require energy to run them, and the question is whether they're scalable. And so, but you don't know that stuff until you get in and do the engineering. So we need engineers to tackle these problems too. And if you can come up with something, that is able to pull CO2 out of the atmosphere at scale cheaply, please sell it to ExxonMobil and all the other fossil fuel companies.
And also, if you figure that out, you'd probably be a billionaire overnight. I know.
Oh, yeah. Here's your chance.
Elon Musk is offering a fortune to anyone who would come up with that technology. He has made that public. So if you know of anybody who has that information, please contact Elon Musk over at SpaceX, also Tesla. Next question. If the entire world stopped producing CO2 immediately, would the Earth's temperature continue to increase?
For a while, it would. Climate is like a big luxury liner, or I was going to say Titanic, but that's not the metaphor I'm looking for. A big ship that once it is under steam or under diesel, and it's moving through the water, it takes a good while to, even if the engines were to cut out, it would continue to move forward for a while because of momentum. And so there is a certain amount of momentum built in, so that if we were to turn off all our cars right now and never turn them back on again, and all the other stuff, there would be a continuation. Now, there is some research just recently suggesting that perhaps that momentum wouldn't last as long as we had assumed. So I think that's still something that's being researched.
And that's also why we're trying to, reduce our emissions, especially from cars, as
Yeah.
quickly as possible. I think, well, what's the year for Europe? 2035? That they're trying to
Well-
get, to zero emissions for all the European nations.
We're all supposed to, I mean, all the countries that signed on to the COPE agreement have agreed to reach net zero by 2050. The problem is that net zero is a promise for future balancing of the budget and doesn't address what we do right now. So we can keep pumping CO2 into the atmosphere in the hopes that somebody would come up with some gizmo that works at scale to pull it back out again. And if that doesn't happen, then we're really even in worse shape than we are now. So we have to be very careful about relying on net zero as targets.
Is one last question before we
Sure.
end this evening. What is the cleanest way to get power other than solar?
Hydro, probably. Now, hydroelectric doesn't have, I mean, it has its own issues, right? It has, blockage of fish migrations and things like that, but those can be addressed. I think hydroelectric is probably a good choice. If someone would invent a good, safe nuclear fusion reactor, that would fix it all. But it's right now fusion only gets exploded, and it's very difficult for us to do it at small scale where we can not blow ourselves up.
Awesome.
Wind, a small scale wind is probably another good one. It doesn't have to be the great big rotors, but farms used to have windmills. I grew up in Missouri, and you'd always see these old windmills they use for pumping water. And then they took those things out and replaced them with diesel pumps. There's a lot of small scale wind we can do.
Well, thank you so much for this evening, Dr. Wagener, and be sure to tune in for part 2. And that is going to be for next month. We always do this at the last Mondays of each month. So the next one will be on the 28th of February, same time, 5:30. Be sure to sign up and register for that. And on behalf of the Danbury Library and the Friends of the Danbury Library, I thank you all for joining us this evening. And until next time, be safe.